Good morning, everybody. Thank you for being here, and thanks AppSec for having me. And today we're going to talk a bit about analyzing traffic. It's not only about traffic, it's about the whole application. And we split in some steps. I try to show everything. I have a bunch of slides, so I will try to cover all the slides. And so just a quick introduction. I work as security administrator at Sucuri. I have 2 patent pending technologies. I used to do research, and so I started to have pictures as this. So I just moved back for system administrator because I was getting too crazy. I'm an open source guy. I really like to share information, and so like if those research were only mine, I probably do some scripts and publish at GitHub, but the company didn't allow. I do triathlon on my spare time. Not really on my spare time, but I do a lot of triathlon. And I'm a dad. I have a 6-month baby that is making life a little bit busy, but that's awesome. So just a quick overview about my company, since they are paying and allowing me to spend my time on that. I work for Sucuri Security. We have like mostly malware removal, and we have Cloud Proxy, that's our product. So most of the ideas I'm going to talk here, we use in our product. So I'm just sharing something that for real life. And I heard that we have Joey here, that he's a sales manager, and he's giving 3 months trial to everybody that talks to him. So if you want to talk about techie, talk to me. If you want some trials, talk to him. And I have some challenge on the middle of the presentation. And I don't have too much stuff, but I have this to hold beers. So that's awesome. And if you answer my challenge, the right answer, I'll give you. All right, if you answer, I could give you like just 3 guys answer. So I did my talk based on WordPress. Like that's just a conceptual idea. There is no big secrets. I use WordPress because mostly talking about CMS, I think the market use like 23% of CMS are WordPress. So that's a good number. So our motivations, behind the talk, is we would like to do something different. We don't call really WAFI, like we're not a competitor with Imperva or Mod Security, stuff like that. We have some different approach. We have a big focus on some technologies. So we mostly try to do less rules, since we are working with whitelisting, and have better performance. And a kind of not too hypey, like we protect against all days, not really, but since we're working with the whitelisting, we have better protection for 0 days. So our agenda, quick introduction, the 5 steps, the 4 steps that we use here, some challenge we have, and some conclusions. We have some ideas about some projects that maybe we could put under the OWASP project. That would be great, so we could share more information and make web a safer place. We could not make that safer, because if it's too safe, we don't have jobs, right? So you need to balance. Just a quick question. Who watched the SMS Hacking 101 talk here? Nobody? That was a great talk. They have some good hacking stuff on the talk. And I will mention like some hacking that he did that I thought it's very interesting, and how we could protect using our ideas. That's very fun. So just to normalize the concepts. Like reverse engineer, it's really analyze something, understand how it works, and duplicate or create something similar, or in our case, we analyze and create something to protect. another quick slide. We are not looking for bugs or security flaws. We don't care about that. For sure, if you found something, that's good. But we are looking for traffic. Like, I'm a system administrator, and so I love PCAPs. That's what I love. And so, like, if you look for whitelisting, I try to find something, and I found this NIST publication. It's a draft, and they don't talk exactly about web application whitelisting. They're talking about softwares, regular softwares. But basically, whitelist is like to run something, you need to be on this way. If something is a bit different, it's something like we could consider malicious, like uncommon behavior. So whitelisting is like I analyze, I see how it works, and so I create something like must be on this way. That things, if you think about that, it's kind of basic, but sometimes it's too hard to do that. Like, if you talk about the whitelisting softwares, like there is much more malicious software than non-malicious softwares. So it's much easier to allow the non-malicious softwares instead of block the malicious softwares. So I really like this concept about whitelisting. And so in our WAF detection, we are going to analyze traffic, application structure. So we are using the WordPress stuff and analyze the file structure. And so see which are the more important files, how the attacks handle those files, what we should prevent to have access to those directories. We talked about the headers and some behaviors. Because behavior is important, because like if you try to just drop on the request, sometimes it's a kind of impossible. You need to have more information, some thresholds and stuff like that. And so, like as I said before, we are going to use the WordPress as base, but you could convert the idea to any application. Some applications will take a lot of more time, and some application is a kind of easier. Or maybe if you do in the future, as we're going to talk, you create some WASP project. You could have a lot of information ready to go, so you just use that. So we have 4 detection steps. What is the 4 detection steps? That's a kind of, we reverse the traffic. So we generate traffic, and we analyze traffic, and we see like, what is a regular traffic? What a normal traffic will do. And so we analyze the application structure. So like, we have a bunch of files. Oh, you look into the directory of application. You have 100 files, 1,000 files. So probably you could not cover all the files, but at least you could cover the most important files. So we have a kind of local protection and hardening. We need to mitigate and the attack surface, because nothing is 100%. Like, so if you do those protection, like you reverse the traffic, and so you create like the good blocks on the request, you analyze the structure, and you protect the most important files. But nothing is 100%. And so you need to have some local mitigations. And you're going to talk about that. And the talk that Greg did yesterday, we covered some things that he showed, but if the application were using something that we are talking here, you're being protected. And the statistical data. So I have a pleasure to work in a Disneyland, because we have a lot of information. Like, we handle traffic from like thousands of domains. And so like, we have a lot of statistical data that you could provide some tuning. And talking here, like all those steps, they talk to each other. I will get more in deep in each step, but the statistical data is awesome. Like, we detect a lot of new behaviors, new trends, stuff like that. So the very first step, let's analyze the traffic. So when we talk about traffic, web traffic, we have like, are you hearing me okay? This is working? Okay. We have like a bunch of information you need to analyze. So this is a kind of mind map. Probably have more or less information. But we have the HTTP protocol, so we start like looking on the, not really on HTTP protocol, but the IP source, the method. So we have the URI, we have the headers, the request and response. We have the bar request, HTTP version, and status codes. Like mostly, I put here the most common header information that we handle and we use to protect. So we start to do some analysis. So first, we need to do some crawling, some spidering. So for this sample, I just use here, I use Burp. Everybody use Burp or Zappy or anything you want. So what's the good side about Burp? You have the spidering, and you could emulate a regular user. Like, where's the first step? I have nothing. Like, I'm talking like, I just have an application that my developer wants to put online, and I need to protect. So what do? I spider. That's the easiest way to see what's going on. Because if you talk to the developer, most of the time they will not tell everything what's going on. So I just like some crawling here. So I start to crawl everything and find information, follow the links, and try to catch and to create a real sitemap. Here I have some parameters, like in this case, but we use Burp for that. And besides using Burp, what you need to do? You are crawling the information. So you need to run a cpdump in the server and save a pcap. Because like in future, you don't want to do all the time the spider. So you have the information saved, and so you could create some scripts and make the work easier. Like, because like who is system administrators here? Only one? Most of the developers? And like system administrators, like we are lazy. We like to script everything because we don't want to do the same task every time. So we need to crawl, save it at the pcap, and so test again and again, but using a pcap. That's much easier. And so you could have like some T-sharks and Wireshark Kung Fu commands that make the parsing pretty basic. So looking at the GET request, like a GET request is pretty basic. So what are you looking when you have the traffic? What do you look on the GET request? Like you have the method here, so you have the URI here, and here you have some variables. What's the good about the Burp? They have they put some colors, and so they make a lot of easier. If you want, you have the params here split it in a different tab. But here you have like a username, Rodrigo, ID, and parameter X, and just simulate something. And when you're looking here, what you need to look like, I don't know nothing about. So I know username will be supposed to be only words, correct? I don't think nobody has @ in name, or they don't have like another special characters on the name. So what do? Like you see like, oh, so username will be mostly space, because maybe you have two names like Rodrigo space Montoro, and words. Nobody have numbers on name, unless unless your dad is a big hacker and want to have your hacker name, right? Like with 0, like my nickname. Like you have ID here. ID is only a number. So what's the point? Like if I look like if ID is a number, why are you try to compare with a lot of different things? It's not easier like I just get ID equal, I create a regex like a number. Anything different from a number for me is malicious. Doesn't matter. a simple word is malicious. And in the previous talk, the CMS hacking, like there was a flaw in a core file of Joomla on that case. And what he did, like just discover, he changed ID to something else than a number. And so the application broke, and so and showed oh, you have a wrong carry, so you just need to fix and put the correct carry. And so he could like access the whole database. But if ID, you have a rule that block only for a number, you will not have that problem. You could have still have the bug, because like the bug is there, but you kind of have a virtual patching. They're not going to have access to that bug. And there is no sense. It's a kind of like when you go to the bar, like you want a beer, right? You don't say like, I don't want whiskey, I don't want vodka, I don't want Red Bull, I don't want Coke, I don't want, no, you want a beer. You go straight. And so the protection needs to go straight or something you want. So another point you need to take care is like user agent is very important, like very important part. I did a research in the past, like malicious user agent, they used to be smaller than regular user agents. Another very important point, HTTP version. Like if you look on the RFC from the HTTP 1.1, they say like HTTP 1.0, for example, is not waiting for the host header. And so like that's a kind of mismatch. Like if you see like HTTP 1.0 with some hosts, that a regular browser will never send that. And so like another point here, that the number of headers, that's very important. Like on my previous research, if you look on the number of headers going to your application, like if a regular browser usually is more than 8 headers on average. And the malicious guys, they don't care too much about RFC and that stuff. They just want to send traffic. They usually have 3, 4. So that's kind of stuff we need to start to figure out. So like that's a regular request. And it's all about how you look onto the request. Like just maybe change how you look on that. Another, just to enumerate a post request, a post usually you have the post method, you have the URI here, and the content, you have the bar content just over here. Usually when you have like some buttons and stuff like that, it's supposed to use post, since it's a kind of more secure. And you have the information here. One point you need to really pay attention when you're creating blocks, and some attackers really take care about that, and some are not. You have some extra information that the button will add to the request. And so I will show like something that will show. Another point, like we have the variable PW for the password. Like that's kind of, you could not whitelist, right? Because you're not going to whitelist and say, no, you just could use like some words and number. So they just use some bad paths. Not they are using good paths. Users are users. But one point that we will figure out here, like since you have a lot of statistical data, what we could do, we could grab the top 100 passwords and just make sure that they are not using that. And so we're not whitelisting, but we're just making sure that they're not going to use some dummy password. Because that's the only way you could make sure that they are going to use a good path. Or at least they are not on the top 100. When they brute force, it will be really quickly. So I was crawling, and I found that I thought it was very funny. You could get a job from headers. Ask me how. That's funny. I was just playing with Burp. And so like xhacker header, if you're reading this, you should visit automated.com/jobs and apply to join the fun. Mention this header. And so I just access, and they have a lot of jobs over there. That's a good way. Like at least they probably are, oh, at least they look on the headers. And those guys, they are the WordPress creators. They keep the stuff running. They have a lot of jobs listed here. I thought this was a joke because I was trying to do something illegal. But no, it's real. They really want to. Like, if you're a developer, they have a lot of jobs there. But what I want to show really here is the stats code. Like, the stats code is when you do some requests, you have a stats code. When it's okay, it's 200. We have a couple of different codes. Like, some codes are for internal, for server errors. Some codes are for client errors. But like for us on this case here especially, we are going to use 200 as the good code and the 404 that's not found as another code. Like, because like when something malicious or some bot or some scanner is running, that IP will generate a lot of 404. And so like in the end, like we have a request. Lost some time. We have the request, the full request here, like a regular browser. We have the header. We have the information here, and so that we receive a OK. Okay, stats code OK doesn't mean that this password it's OK. It's just answer from the web server. And so after you do this really basic, like you need to spend a lot of time looking at the traffic. Like as I showed, like with that GET request, you see like sometimes the application have a lot of variables, so it could take forever, but it's worth. At the end, you could sleep, like and figure out like, okay, I could sleep a bit more, like because nobody's going to hack my website on the middle of night. And so I create like maybe in future we're going to release like a tool, because there is some big difference about release something and the code that I do. The code that I do is not something I could release because I do something as system administrator. That's to make my life easier. And so I start to analyze some traffic that I saved and that PCAP. That's why I told that saved at the PCAP, and so you could keep work on that. And so I create some regex based on the URA. So here you probably have numbers, and here you have some words and space, and could be things. This is for search. The page ID is only numericals. So like here's another search, and so I create some regex and run against my script, and so I have like those URL will fit here and those will fit here, and so I could use those regex just to protect my application. I could create some web application file. I could add something on Apache, or add a simple if inside Nginx. Doesn't matter. You could just add these regex and block the traffic. And so we have, for sure, you have a couple of information that will not match. And so that kind of thing you could analyze and reanalyze and make sure that's not malicious, or maybe you're missing some regex, some stuff like that. And the good side, like when you're deploying this, you could deploy like on the IDS mode. I came from the IDS world, and so like you could just deploy on monitoring mode when you're using the real traffic, and so you could fix some false positives because probably you missed something, and so you have like some traffic that you probably need to do some new work, or maybe you probably those regex will get some regular traffic. And so just a quick challenge, like you could keep your beer a bit colder. What's wrong here? Like where this is malicious? Just to see if everybody's awake. Any guess? The username. Here? No, no, no. That's not. That's a try. One more try. All right, who tried? I didn't see who. Who? The IP? No. The GET? Not really. Like, what's wrong here? Like, we have a Mozilla running Apple, Chrome, like not a real new version, but no browsers will use the HTTP 1.0. That's why it's wrong. Who gives some suggestion? Oh, I have one more. Maybe 3 people will. And how about here? Besides being an IP from Ukraine. No. I'm not talking about missing, because we don't have the whole information here because it could not fit. You remember when I saw, like, when you post at wplogin.php, remember that the button adds some information to the content. And if you look here, the post log, they just have the log and the password. So it's not a regular request. It's somebody trying to do some brute force. Make sense? Got it? Just come back here quickly. Like here. Like when you have the full request, you have the log, the name, and the password. But the button, if you're a regular user, a real user, they will add more information. And at that case, it's missing. They just send the user and password. Probably a brute force. Right. And so that's the summary. We capture the traffic, and we split the traffic, headers, math variables, all the information you to work, and you figure out that it could block, because maybe you could block more stuff that I could. Because like we handle like 1,000 different websites, so you cannot block everything because you have a lot of different customers. That's hard. But if you have your own server, and you could block probably more things. So you split the traffic. You compare variable against regex that you create. If you don't have, you could create new regex. And so we test with real traffic. And so everything works. So you grab a beer. That's it. So that's the first step, the analyzing traffic. So the second step, we need to analyze the file directories and structure. And so we have file directories, permissions, monitoring stuff. And so like if you get a WordPress tarball, you have a lot of files. If you Google about some guys read some stuff about the files, about directories, that's real cool. But you need to focus. Like if you take care about all the files all the time, you get crazy. And so what's the basic structure? Config files and installation files. Like if you like in the CMS hacking talk, like sometimes to figure out the version of the something, he just have access to changelog or readme stuff that is inside the WordPress or Joomla installation. So we need to take care about that. You have a very important file, wp-admin, that you have all the admin stuff, usually like when you have where you could log in as admin of the web or the WordPress site. We have WP includes that are core files. So when you get infected, like that, those files could just be replaced with the other tarball files. And so you have WP content, you have themes, plugins, uploads. You need to take care especially on uploads, if you allow uploads. You need to really take care about that. And you have like the XML RPC.php, that's file they love to attack that, and I will show a bit more about that. So what is the XML rpc.php file? He's supposed to handle comments, but comments comes with spammers, so that's a kind of stuff that we need to balance. They could ping back. He could ping a website. I will show here. So they use for DDoS attacks. And we have some blog posts about that it was crazy because it was enabled by default. We have user auth. Like if you use this get users blogs, you could brute force. And so like we are like protecting only WP login, like for brute force. And so we saw that they're brute forcing using the XML file. And so like we need to protect them. Or if you want to have some fun, you could like maybe redirect for some running pods and show who is the boss. Like you rack, what do they say? Like you rack my blog, I sniff your packets. Like that's a kind of sharing needs. And so here a sample, like I'm talking about the XML RPC login attempts. They access the file, and so they send the user here, that's a user test. So never create a user called test, because you probably use some bad password, because you say, no, it's just quickly, it's temporary. And those users stay forever. And like the password here on this sample is sick boy. So they're just brute forcing. And like we take some time to figure out that. And so we start to really understand the API behind this file. Some brute force. So here is a brute force. That's why we found this they are using. Because like we figure out like we are protecting the WP admin. So we are good, but we are not that good. So that's amount of requests we got on that period. Like it was like, I think like probably here in the beginning of July they discover that. And so it's a kind of, they share a lot of information, I think, between them because that's crazy. And so suddenly it starts more, and so a big spike, and so like here in the middle of July they start to go really, really hard. And so what you did, like that's the problem. Like XML, RPC, they need to have access to that. So we create a rule that if they have the XML file, XML access plus the WP blog users stuff, so we are going to block. So the pingback. Did somebody hear about the DDoS using the pingback? You did? So basically, like you could use a command line, any WordPress, hitting the file, they have like a method name called pingback.ping. And so you put the victim site here, and they start to send a request to that website. But any WordPress could be used because it was enabled by default. So you could like go to Google, enumerate like 100,000 of WordPress, and just create a script and probably your DDoS and so you get something like this: 162,000 WordPress websites attacking our customers. And that's what's crazy, because like is a kind of regular traffic from real IPs. It's not kind of a racket IPs, kind of being racket, but it's not real racket. Another point that we need to take care is WP admin access. I mean access because like we're like for here we're like that's the fun part. Like usually have a couple of blocks, real blocks here, and suddenly have some spikes. And so we have spikes, and when we really get in deep and find some new things, like This like 63,000 attempts like a week. That's some numbers. It's not usually that number. Sometimes it's much more, sometimes a bit less. But imagine like we block like a lot of attacks like for WP admin only. And some customers, they just disable this protection. So like you don't have logs for that. So probably they have much more access to the information, but we don't know. It's up to the customer. You just have we have this feature, but it's up to them. So sometimes it's hard because some websites, they need to allow anyone to log in, right? And so just quickly, some AJAX restriction files, the uploads. Like if you do options index, like a lot of people could upload, but if you don't want that all the information get listed, so you could add this to make sure that not going to list. And this you are not allowing from outside somebody have access to a .php file. That's a very simple, but like when you allow uploads, they could upload a web shell, right? And so if they upload a web shell, they could like start to send some commands. But if you have something like this, you avoid that. They could upload, but oh well, like they could change the extensions and all that stuff. You need to really take care about that. And so like WP admin, like if you could allow only a few users, a few IP servers, that's much better. But if you have a regular browser, a regular blog, that's kind of hard. The XML RPC, we block by default in our service. So if the customer need by any reason have some access, we allow everybody to have access. But we have some rules, as I told, like in the correlation logs, to keep a kind of protection. And here are a couple of more samples, like block like text files, log files, just make sure people, by mistake, some information is over there. And so another point, like the third step, local protection and hardening. So you need to mitigate. As everybody knows here, there is no 100% security. And so we want to mitigate. So what do? You just cut the Ethernet cable and make it offline, so you're good. But how you do that? We have some tricks here. We have real-time monitoring option. Like you could download OSEC, it's an open source project. And like besides all the features that they have this awesome feature for Linux that it's used the iNotify functionality from the kernel. So in real time, if somebody change any file that you think it's important, any extension, they will just send you alert. That's very interesting. Like talking about the CMS hacking, I don't know. I don't know why Greg needs to do something on the server for them, and so they just give a kind of admin access to him to the WordPress. And what he did, he just removed the 404.php file content and change for a web shell because they don't want to give a shell for him. And so he just did that. If you have this running, you get on the right way. Why they change that? If you have a malware infection, why they change that? Why they create new files? And so, like when you have some infection or somebody hitting your server, you have like to monitor this in real time. Like if you read the Network Security Monitor, the book, like how about how fast you could detect the attacker? It's not about like prevent 100% because it's a kind of impossible. The attacker will always have access if he wants. That's the biggest truth in life. But you could try to make the life difficult. So another threshold ideas that we have, that you saw, too many 404. Like who generates? A regular user will not access a lot of not found information in your server. So or it's a bot, or it's a web scanner, or it's something malicious. It's not a regular user. Another threshold like get per time for the same IP. Like a regular IP will not send too much information, like too many gets. Like I'm not going to send like 50 requests in 3 seconds. That's not common. Post the same concept. So that's kind of idea that we saw that we could create. Like we could monitor a bit and get some times and thresholds, and so we could add that. Special file permissions. Like, do you guys know a command called change attribute in Linux? Like, we have like, I'm just simulating a quick infection. Like, we have like echo malware content to test.php. So cat test.php malware content. So we list the permissions, and like Spooker, they have permissions. That's okay. And I list the special attributes now. Like I just did chat is CHATTR plus I. And so we become this file immutable. And so like if I'm Spooker, still Spooker here, I try to add a content, I don't have permission. So it's a kind of paranoid. But if like the AppSec server has that, like Greg will not get the web shell, because like he could read the content, the web user could read the content, but he could not add information. So you need a root to change the permission of all files, and so because most of the time, unless you are upgrading your WordPress, the changes are on the database. The files are all the same. So that's a kind of stuff that you could add. That's a kind of paranoid, but that's a kind of very nice. I think I'm running out of time. And so just to finish the fourth step, some statistical data. So statistical data is where false positives become something interesting too. Because like you could figure out what I'm doing wrong, or maybe how I could improve that. And so we do some counterintelligence, like work on behaviors, alerts to catch new trends, like those blog posts I mentioned before. Like it's a kind of new trends. Like when you release that, everybody starts to figure out, oh, we're being attacked, and stuff like that. And running pods, like we have kind of real life running pods. That's all we have. Because we have some clients that people really try to track that. And so like behavior is all about how you look on the problem. Like if you have like some 3 user agents like this, only 3 samples from 1,000. I can just put that. How you're going to protect? Like what you're going to create? How you're going to behavior that? Any guess? Like we usually look on different approach. Like you could tell me like it could be A, B, C, D that you have in everything. But if you look at A, B, C, D, that's why it's a blacklist way of doing stuff. So if by any chance the attacker just changed D for E, you're out of game. They are still. But what is common here? All the user agents, they have like 19 bytes. That's how you try to look things different, because sometimes it's a kind of crazy, like too much information going on, and you need like, oh my God, what I need to do? They're going to win the battle, and so we figure out, oh, they are missing this. And so we try to see anything like we could. So some statistic, like we block like in a week, like a lot of access to XML. And if you look by IP, like USA is the most country that attacks. But that's common because like I think most of the hosting and infected machines they are hosted in US, so that's pretty common. And so China in second, and so a couple of more countries here. And so like one point very very interesting, if you're doing to create some protection, use gel IP. Like I could If I'm not wrong, like 40% of our blocks is JIP. The customer could set, like, I don't want traffic for this and those countries, and so they could just block. And so 40%, that save a lot of performance and traffic and CPU. The top method, so get is the most used. Post is is in second. Head, trace, cook. I don't know what's cook. Return to cook. I think I'm out of time, but if you could stay a little bit before lunch, I could finish. And some stuff like here. I'm just finishing. So HTTP version 1, as I told you, like regular browsers doesn't use HTTP 1.0. We have some scripts and some bots that they use. And so like we block like only for a week almost 1 million requests using HTTP version 1.0. And I think because they have the big fire of China, they could not update their web browsers. And so poor China, they have some very old browsers. So they are the top one here using HTTP 1.0. Ukraine, Singapore, like that kind of traffic. Like if you have something related to US, like you don't want traffic for a lot of different countries. Brazil, we're here. And so in summary, like we reverse the traffic, analyze the application structure. It doesn't matter